manufacturing. It's about technical valve selection as well as types of the valves.
Okay.
So that's what is my today's presentation is going to be. Just a minute, just I will share the presentation now.
Right.
All of you can able to see my presentation.
Yeah. Yes.
Yeah, it's visible.
Okay, it's in full screen only, no?
Yeah,
Yes.
it's full screen.
Okay, right. So today we are going to see about this valve selection and types. That means the right method of valve selection as per guiding standards. So these are the general standards what we are got approvals and what we have our products manufacturing standards. So today just we are going to give a small introduction about the company and then valve selection parameters, valve types, products offered, what we are offered, and utility management solutions based service offered, and question and answer. First, today actually we are going to do first three only. That is introduction, valve selection parameters, valve types. The products offered and the utility management solution we are going to see on next sessions, upcoming sessions of next week.
Right.
So Lehry, as a Lehry, if you say that it was started in 1950, almost 70 years old company, which is actually a great great thing that I have part of this company on the 70 years old company. So we started our own manufacturing in 2006. So we manufacture valves, we started our manufacture of flow meters, electrometric flow meters, water meters, and also we are doing automations like over tank level control system, pump control systems, as well as water metering systems, which is the talk of the town right now. Because water is going to be scarcity for everywhere, so everybody is looking to monitor and make accountability for the water. So that's we are in pioneer right now. We have very good technology of wireless technology. We have 3 factories, and we have pan India offices. Almost all factories we have all India. We can able to reach, as well as we have offices in overseas.
Right.
5,000 plus customers in our thing, and we are serving infrastructure field as well as industrial fields both. So MEP like infra in plumbing, firefighting, HVAC, all 3 verticals. As well as in industry, if you say process and utility both. And we are also OEM to various companies like Grundfos, Swingsetter, Vilo, Luby, Ebara pumps. So various pumps we are supplying as OEM products. And we have certification of ISI, FM, UL, NSF, CE certifications products. So as I explained that earlier thing, the same on 1950 we started as a Lehry Brothers. In 2006 we started in Lehry Instrumentation Valves Private Limited, and this ISO certification we got for our company. We have a very good, excellent technical support team. That is the major advantage of a Lehry. Even though when we are doing in olden days, that time also we are well versed. Before manufacturing also we are well versed for the technical support. So we have the excellent quality of products. After sales service is more important. And our core business is manufacturing of various valves types of that I explained: plumbing, firefighting, HVAC, industrial application, mostly in automation systems.
Okay.
So that we are also supplying to government bodies all over India. We are one of the preferred vendor for metro rails. So most of the India, most of the metro rails we are supplying. Chennai Metro, Pune Metro, Bombay Metro, Mumbai Metro, everywhere we are supplying. Also, right now we are also going to supply to Cochin Metro, like that. So OEM, we are various pump supply here. So our presence, I explained all over India, we have their presence. So certifications, as I explained, is ISO certification for our company, which makes us documentations properly, and FM approved certificate. So these are very few companies in India. We are the only company have FM and UL ranges for all sizes, all products.
Okay.
UL listed, and this is NSF certification. The NSF certification basically is for drinking water application. So for US, UK and all, they will use the product which have NSF certified products for drinking water or domestic water application. We are the only Indian company have this kind of certification, NSF certification for valves. These are the products listed in NSF certificate. And ISI certificate. For Indian market, we are also having this ISI certificate for butterfly valve, gate valve, check valves. These are major things which are required for plumbing industries. Also, we have this BSI CE certificate. CE certificate for this is for gas applications. So medical applications, medical gas applications. So where they need CE certification, so our valves are CE certified. And the FCRI certificate for water meters. We are also into water meters as we are in water metering system. We have our own manufacture of water meters. So we have single jet, multi-jet voltmeter type water meters, also electromagnetic flow meters. For that certificate, one of the in India, the FCRI is one of the Indian company, government aided company for certification for flow meters. The clientele, we have almost, since we are in 70 years, we have almost touched all the clients. So these are major clients. So we are actually, there are a lot of things we are in first. So we are first in many things. If you take lead-free brass ball valve, we are the first Indian manufacturer lead-free brass ball valve. And we are the first Indian manufacturer have water hammer arrestor. We are the first Indian manufacturer have both UL and FM approved for entire range. We have one of the prestigious thing, live valve experience studio. One of the first company in Asia to set up experience center for valves and utility solutions in India. And still continues, it's going on. So right now we want to enter into technical session that what is valves. So we are going to see the valves. So our major products are coming to the valves category. So what is valve? Valve is a device that regulates, directs, or controls the flow of a fluid by opening, closing, and partially obstructing the various passage. So it's about valve is a device that it's day-to-day life we are using. Actually, we are in kitchen, we are using, in washrooms, we are using, wash basins, everywhere we are using the valve. That is all valves. But before studying this, we will not aware that valve. We are not bothering about that. So, but each and every valve has certain particular quality, particular parameters to check whether it is quality product or not. So we need to understand what is the valves. So what is the purpose of valves? So purpose maybe the regulates, directs, and controls. Maybe you may be aware of everything, but I want to just refresh yourself so that it will be easy for a catch up later. So guidance on valve selection. So valve type selection. How we have to select the type of the valves? So there are various type of valves. So for selection, we have to certain parameters are there to select the valve type. First, we have to record the function. For what is the function of the valve? Whether we have to go into on-off condition or modulating condition or regulating function. So based on the function, we have to select what type of valves we have to select, what type of we have to buy. And service conditions. Service condition, that is the thing what we have. It is a HVAC line, it's a plumbing line, or it's a utility line, or it may be a process industries. So we have to see the service of the condition so that we can select based accordingly, so the material will be selected accordingly. Fluid type and condition. So that is a fluid type means it may be a liquid, it may be a solid, semi-solid, because pulp industry, paper industry, if you take a paper industries, it has the fluid comes as a pulp. If you take a sugarcane industry, it's a pulp, it's coming as like a semi-solid. So for that also we have valves. So we have to select the valves based on the fluid type and condition. What is the temperature? What is that corrosiveness? So based on that we have to select. Fluid characteristics, what I explained, same thing. So we have to select the characteristics. It's a acidic type, or it's a alkaline type, or it's a neutral. So we have to select based on that. We have to select the MOC. What is that MOC we have to select? What are the type of valves we have to select? For example, if you are using a metal ball valve in acid line, it will get corroded, it will worn out, it will actually erode quickly. So for that purpose, we have to go for a rubber lined valve. So rubber lined valve is actually rubber lined ebonite rubber, or it's maybe a nitrile rubber, so that it can withstand the particular chemical line. So for that, we have to select based on the fluid characteristics. Frequency of operation, that is also more important. When you're operating some lines, maybe very rarely we will operate. Some line we will operate frequently. Some line we will operate every minute, every day. In process industry, sometimes we will operate every minute. So it depends upon that operations, we have to decide the valve, so that it is easy for us to control, and it's a life, it will give them more life. Isolation requirements, that's what I say explain. It's for isolation purpose, or it may be a that is a class for the isolation, like class 1, class 2, class 3, class 4, class 5. That is what we say testing standard. So that means we have the 100% sealing, that there won't be any leakages at all. So it may be small, 5 drops, 10 drops are allowed. There are some things we can allow for 10%, 1% like that. So that kind of application, we have to select what type of isolation we need. So based on that, we have to select the valve. So maintenance requirements, how they want the maintenance, because if they have maintenance team, they can buy a good, they can buy a gate wall, or it may be a global, so that they can do service and maintain the valve and keep use it. For in valve itself, we have 3-piece design is there, single-piece design is there, or 2-piece design is there. If you take a 3-piece design, we can able to service and maintain it, but it will be costlier than single-piece design or 2-piece design. But in case of infra, like plumbing, firefighting, HVAC solutions, nobody will be there to maintain, to service it. So use and throw is kind of use and throw. Yeah.
Hi Raja, sorry, can I interrupt you 1 second? It's okay.
Yeah, please.
So what is this 2-piece, 3-piece that you were explaining right now?
Shall I explain? Means just upcoming phase are coming. If you record, I will explain
No
now.
problem. No, it's okay. It's coming up. It's okay.
Yeah,
Your
yeah,
wish,
sorry,
whichever
sir.
is convenient
And
for
now
you.
today we are going to see that general basic classification types of the valves only. Okay, I will show you the with the figures. Is better. Okay.
Sure.
Okay, right. So environmental consideration. So environmental condition means when we say that normal condition, seashore condition, when it's in the nearby the sea, the outer ball, the air itself will make the valve corrode. So for that we have to go for SS316 material, SS316L material, so that it won't get corroded, it won't worn out. Normal our cast steel valve will worn out quickly. So likewise there is a chemical environment will be there. So hazardous environment will be there. So that kind of environmental, based on that environment, we have to decide the valve. So these are the parameters, these are the information we have to collect. That's what I'm explaining. All these things we have to collect the customer, so that we can able to select the right product for them to make it compatible. That means economical or optimum product. So past experience in comparable conditions. For if they have any experience, if they have used some valves, they have some failure, they have some problems or frequency of operations. So in that case, if we can able to, if you have the history of that experience, we can able to select right product for that. That also, if there means, we can collect with them. So simply we cannot, if they ask for a butterfly valve for 3 inches regularly, we can supplement, that will leads to again failure quickly. So it's better to have analyze all the information or back experience, so that we can able to easy to give a right product. Weight and size, that is also more important. So some place we cannot use a big product because of weight. Some place the size, there are valves are that in gate valves we have rising, non-rising. So whereas in rising stem, the stem will comes up and we need a extra space of stem rising, but non-rising we don't need. So there's a very inside there's a charm where if you want to fix the valve, the stem cannot rise, means we have to go for a non-rising stem. So these types and all we will see later. So we will, with the upcoming slides, we will explain the details of the valves. And cost. Finally, the cost is most important. So this is now we will come to the classification of valves. So based on the functions, the valves are classified into major 4 categories. One is isolation category, and regulation, next non-return, and 4th is special. So special purpose application valves. So isolation valves. So isolation means the function itself name that It's only to the open or close. That means isolation purpose. Whenever there is a wherever the flow is required, we will open the valve, and if you don't want the flow, we will stop the valve. So that is open and close function only. We don't keep in between or modulating thing. So wherever the function is required only for isolation purpose, we can go for this type of valve: gate valve, ball valve, plug valve, piston valve, diaphragm valve, butterfly valve. All these are mainly used for isolation purpose. Next, regulation. So regulation means there is a valve which we can able to control the flow. We can regulate the flow or limit the percentage of flow what we need. Just like what we say, if you take a chemical company or if you take any medical company, if they are mixing a valve, in between there is two chemicals are coming, they need 50% of this chemical and 50% of that chemical, they will mix and they will set the valve accordingly, and that much amount of flow only coming from the valve. So that is, we can regulate the flow. So in another next batch they need, this is 60%, that is 40%. They can adjust that thing and they can able to allow the valve. So that can be controlled. That regulation can be do. That means we can keep the valve intermediate position. So in isolation position we have to keep two position only, open or close. But in regulation position we can able to keep intermediate, like we can keep 10%, 15%, 20%. So whatever may be the position we need, we can keep that valve open condition or closed condition. That's what we call it as regulation. The major valve which is used in regulation purpose is globe valve. If you take globe valve, all type of regulating valve, the concept behind is globe valve type only. Next, needle valve is one of the globe valve only. Butterfly also we can use it regulation purpose, but it's not recommended generally. And diaphragm valve, piston valve, pinch valve, that also we can use, but these and all is depends upon the condition we have to suggest. But major thing is globe valve only. Non-written valve. So non-written, I think everybody knows that it's the name itself says a non-written. That means it allow water or flow in one direction, and it won't allow written direction. So unidirection flow valve. This is also called as unidirection flow valve. So that means whenever that water is going, for example, in a pump. So this majorly they use in normally in your day-to-day life we are using a check valve in a pump. Check valve. The non-written valve is also called a check valve. So that means whenever the water comes from the pump, it's going to the over tank. So when the pump stops, when you switch off the pumps, if there is no inertia, there is no check valve, what will happen? The water from the entire line will come back to the tank. It to the sump. That means below sump. That means the entire become empty. That lead to the pump will run and dry run, or it will be empty run during next operation.
Hi Raja, sorry.
Yeah.
So now this check valve and the isolation valve, right? So it's similar thing, right? So open and close. Basically, you're closing it, so the water from the pipe will not come back to the sump, right?
Correct. The isolation
So
valve is a manual operation. We will open and close manually.
Okay.
If we kept the valve in open condition, it will be open condition always. You don't close. If you close the valve, it will be in closed condition. You don't open. Automatically,
So
don't open.
so isolation is more manual, and non NRV is basically automated based on the pump is on or off.
No, it's not automated. It's the thing spring return based. It's a valve which will, that means or how we can say that it's a check valve. If you are having actually, if there is a plate will be there in the body. There's a plate will be there. There's a it's a swing type also is available. I will show 1 minute. I will show the check
No
valve.
problem. No problem.
Okay. Just I will show the check valve photo. Very easy to understand.
I'm sorry, I'm interrupting you this way. Huh?
Yeah, no, good. That when we are having these doubts, it's better to have clarify immediately. Yeah. So can you see these devices? All these devices are check valves. All these models are check valves. So this is, if you see, there is a plate is there. This actually is a wafer design check valve.
Okay.
So there is outer ring plate is there. There is a inner plate is there. The plate is a hinged one. So what it will do, it's like a hanging on the top plate. So whenever there is a water come, it pushes the disc and flow in this one direction. and it goes in the opposite. It goes in the downward side. That is the delivery side. When the
Okay.
pump stops or the flow stops, when we stop the flow in the inlet line, what will happen? The reverse flow will come. That the water which is coming in the downstream line is trying to come in the reverse flow.
Correct.
That time the disc will automatically flow, that means it moves along with the water and stops the flow. It's like a free flow. It's like a free. It's a swing. It's a swinging like this. It's like a normal plate which is swinging in the in the rod, center rod.
Okay. So
So
it basically stops the flow. Stops the
yes, yes,
flow.
stop the flow. So there is no manual intervention here. There is no automatic. There is no nothing. Simple. Its work is to allow one direction. It should not allow return direction.
Return direction. Okay. So why can't this be done with isolation valve if you, it's a
Yes, we
similar
can.
procedure.
Yes, we can do. We can isolate. We can close the valve and we can stop it. The water will not come down. But
Correct.
when the pump stops, every time we have to go and close the valve,
Correct.
which is nobody will do that.
Correct.
So if
Correct.
you switch off the pump or suddenly the power gone, what do you say? If the power gone,
Correct.
if we physically if you go and stop the pump, we can close the valve. But when
Right.
it is power gone, what will happen? That will water will goes down.
So this check valve will automatically detect if pump is closed, the disc will start moving towards the this thing, right?
It's based on the pressure difference. It will work based on the pressure difference. The inlet when we are
Okay.
pumping water, the pressure will be higher.
Correct.
When stops, the flow stops. That means the inlet side there won't be pressure. The outlet side pressure will be higher. So it will
So
try
it
to push
takes,
that downward.
it understands that there's a pressure differential that's happening, delta is
Yes,
decreasing, so it automatically detects and it closes the flow
correct,
or
correct,
stops.
exactly.
Okay, okay. Now I got it clear. Yeah. Thank you.
So, right.
So why is this butterfly valve put isolation also, regulation also? So it serves
Uh,
both the purpose?
yes, actually, basically, butterfly valve
Mhm.
can is majorly used for isolation purpose. They are using
Okay.
for open or closed position. But
Okay.
it has that actually is we can able to keep in multiple position or like 10%, 20%, 30%, 40% like that. There is a
Ah,
plate is there to stop. The stopper is there in between.
ah, okay. So
So
you're
we can
basically not fully closing. You're closing only say at certain level of your
yes,
basic.
yes, yes, yes. So
Ah,
that is
okay.
what
Okay.
regulating.
So
Butterfly we
that
can
is
keep.
regulated. Yeah.
Yes,
Okay.
yes, yes. Butterfly
Right.
we can use it for regulation purpose, but it's not recommended. The models are the different models are there for regulating purpose. The
Okay.
design itself butterfly, but models are different for both applications.
Okay. Got it.
Okay, right. Next, that NRV. So as I explained, the NRV purpose is to
Backflow.
stop the return flow.
Yeah.
Okay, that has check valve. It's also called as a check valve or non-return valve, NRV. All these three terms are same. The
Ah,
types
okay.
may be different, models may be different, but all are same only.
But you also said before that's NR
NRV,
non-rising. Oh, that's NRS. Sorry, forget valve. Yeah. Yeah.
uh, that non-rising, rising, and all gate valve.
Correct. Correct. Yeah.
So yeah, NRV is non-return valve.
Correct. What is the sluice valve is gate valve, right?
Yes, Lewis valve is a gate valve only actually.
Ah, okay. Okay. Done.
Lewis is a design kind. That is why it called Lewis valve.
Sluice. Okay.
Also in Lewis valve only that rising stem, non-rising stem will come. That is NRS, OS and Y.
Ah, yes.
NRS means non-rising stem.
Yes.
Okay. Here NRV means non-return valve.
Non-return valve. Okay.
Okay, right. Backflow preventer also is a NRV. It's actually a double check valve. That
Okay.
we'll see. That is a big market. We'll see later the detail about the backflow preventer. It's a
Mhm.
one class is separate required for that. And a special purpose valve. Apart from these three applications, so there are some more applications valves are there. That all will come. We categorize in special purpose valve.
Mhm.
Multi-port valve. That is one valve is multi-port valve. So multi-port valve means instead of having two port, it has more than two port. So for example, in one inlet, one outlet. Instead of that, if we have one inlet, multiple outlets, that is called multi-port valve, or
Okay.
else different direction valves. In RO plant, you can see that in RO plant or normal diverter valve, we can see the diverter valve. So when we do back wash, we'll do this. We use this multi-port valve to divert the flow. That is kind of valve is called multi-port valve. Flush bottom valve. It's one of the valve which is used in the industrial application where the dust ash and all is coming. The collecting pit. They will put this flush bottom valve in the bottom of the tank or cone, whatever may be. So what it will do is it will remove when we are opening the valve, that entire that entire tank will get empty by opening that. It will not get stuck in the seating area.
So basically, all the sediments will be cleaned automatically.
Yes, exactly. So it's used in bottom. If the flush bottom, normally it's installed in the bottom of the tank. That means not in the general tank. It's mainly for because general tank now water tank and all we can use normal valve at all, normal valve itself, so that we can able to clean the water when it's coming in water only, so we can clean it out. But in industry application, the ash, that waste, all other chemical waste which is coming into collected in a pit or in a tank or in a separate vessels. So for that purpose, they will use this fresh bottom valve.
Okay.
Next, float valve. I think float valve, you are aware that all over a tank or in flush normal our system, that is in our the western toilet, we have the flush thing, no? That has internal float valve is there.
Okay. So
the
float valve is
inside. Yes. So the valve will actually close. It will automatically close when the tank fills. So the flow, it will allow flow when the tank is lower. So it's automatic tank filling valve. But this valve also some have minus points. In small gravity flow, low flow, it can be used. In low pressure, it can be used. But higher pressure and higher flow, it cannot be recommended. We have to go for a system. So that's why we are recommending for over tank level control system, separate system for that. So ball float valve is all actually failing quickly.
Okay.
But in system, that small application where one tank to another tank they are filling, that time they can use this float valve. And foot valve. Next is foot valve. Foot valve is also actually is NRV. I have to put it in that category also. Foot valve function is installed in the bottom of the pump, every pump.
Okay.
So we have to this foot valve function is actually NRV only. It will allow water in the one direction to stops. Whenever the pump stops, it will retain the entire head. So, for example, if you are using it in a water tank in a sump, from sump, if you keep a tank separately. So, for example, pump separately. That if you above the ground, and we are laying a pipe inside that sump, and there's a 1 meter or 1.5 meter tank depth. So if you when we are switching on the pump, it will try to suck the water from the down and pumping it outside.
Okay.
When you switch off the pump, what will happen? The water which is coming in the downward direction, which will that 1 meter pipe length, water will goes down to the sump.
Okay.
If it goes, that means the water become empty. That pipe will become empty. Which leads to the pump will fail quickly, because when during the running condition, if the water is required to rotate the turbine. If you are rotating the turbine inside the pump, it is rotating turbine is there. The turbine is rotating without water, which will leads to failure.
Yes.
So that's why the foot valve is mandatory for every monoblock pump, or it's a surface pump. We call it surface pump. So the foot valve is installed inside the tank, inside the sump. And line blind valve. This is actually a fully industrial valve. It's to generally to blind the end line. The valve can be used. We can keep this open condition, and we can keep it in blind condition. That is to make it maintenance purpose. When you are doing maintenance purpose, or to avoid the line, they'll use this blind valve. This is a truly industrial product. And pressure and vacuum relief valve. So pressure relief valve and vacuum relief valve, there are two functions actually. So I think pressure relief valve, you might have that. Pressure relief valve, you might heard about that, aware of that product.
I mean, yeah, we keep seeing PRV somewhere. That's all.
Yeah, PRV, there are two things are there. PRV means pressure reducing valve. That also they call it PRV. Pressure relief also is called as pressure relief, PRV. The function,
Okay.
both the function is different. Pressure reducing valve will do, for example, if you are giving a 10 bar pressure of inlet line, but we need 3 bar. We need only
Correct.
3 bar pressure. So we have to reduce the pressure. For that application, we have to use pressure reducing valve. That
Okay.
function is called as pressure reducing valve. But when the pressure relief valve means it's like a pressure cooker. Whenever the pressure increases in the line, it
It
has
takes
to
it.
release the excess pressure. A
Okay.
typical example for relief valve is the pressure cooker only.
Okay.
The pressure keep on building in the cooker. When it exceeds to the particular pressure, it automatically opens and releases the excess pressure.
Yeah.
Again, it goes to close condition.
Okay.
Likewise, for example, if the fire line, if you take a fire line, the fire line will have to maintain 7 bar pressure the entire circuit. Whenever that pump will run automatically based on the pressure switch. So whenever the pump pressure goes low, the pump will on, and pressure reaches high, pump will off. They will set
Yeah.
7 bar stop pressure. In case the pump pressure failed to give the feedback to the high pressure, what will happen? The pump will keep on pumping water. When the pump is pumping excess water, if there is no opening in the end, there is
Correct.
no valve open, what will happen? The pressure will keep on building up in the pipeline, which leads to
So,
a complete burst.
pipeline system might explode, right?
Yes, explode, exactly. So to avoid that condition, what we will do, we have to put a one T and put this pressure relief valve in the pipeline. So what it
Okay.
will do, we have to set the pressure at 8 bar in the pressure relief. If you want to maintain 7 bar in the pipeline, we will set this 8 bar in the pressure relief valve. So whenever
Okay.
the pipeline exceeds 8 bar, automatically it will open and releases the excess pressure.
Okay.
That will safeguard the entire system instead of exploding or bursting.
Oh, interesting. Okay.
So
So
this product is
same
made.
thing for vacuum. Same thing for vacuum, right?
Yes, vacuum. So whenever there is a vacuum is created, like if you see there is the temperature difference, even in the hot water line or in the geyser itself, they given the vacuum relief valve. Whenever there is a water is getting heated up, there is a steam will generator and the pressure will build up in the line. So when the
Yeah.
procedure of that steam will cools down and the water it will become water droplets. Whenever the
Correct.
steam is that area is higher, when it cools up, the area become very low. That means the density of water is higher, so the area will become reduced. That means the vacuum created in between inside the tank. That needs
Okay.
it has to need some air inside to fill the vacuum.
Okay.
So in
Yeah.
case there is no water, there is no air, then it will become it will damage. That means it will collapse.
Correct. So basically, basically the valve is having condensation, so your surface
Yes.
area is decreasing.
Yes, exactly, exactly. So we have to
Oh,
use this vacuum relief valve in that condition. Wherever the vacuum is creating that area, it has to suck the air and allow the air inside to avoid this vacuum condition.
okay. Yeah.
That's why it's called vacuum relief valve.
Mm-hmm.
So these are all very special application valves. We have to.
This vacuum, hello, this vacuum relief valve,
Hmm.
the medium is only for air, not water, correct? No?
It's the flow which is coming outside to inside is coming
No, no,
air.
no, whatever. No, no. This valve can be used only medium, only for air medium, not water medium.
Not like that. In water medium, so what I'm telling is, so for example, in a pipeline, it's filled with water. In the
No,
top,
for example, in a pipeline, if the pressure goes up, so what will happen? If the medium is water, the water
hmm,
has to go out. No, it has to
that
be
is
uh,
that we cannot
released
use this.
out.
Hmm.
There we can't use it. This here the medium is air, not water.
Yeah, it's so I will explain the difference between this. What you are telling is medium is air or water. Inside the
Yeah.
pipe, it may be anything, but that water, for example, the pipeline is filled with full of water. The vacuum valve also, the vacuum relief valve also will have
No,
touch
no,
with
no.
water.
I'm talking about the pressure release valve.
Pressure relief and vacuum relief. Yes, yes. Pressure
It's
relief
air.
is to relieve the excess pressure of water or whatever media in that line. Vacuum relief valve is to admit the air inside the
Yeah,
pipeline in case of it
that
will become
that
empty.
yeah, that's clear. I agree. I'm
Hmm.
talking about only for the relief pressure relief valve.
Pressure
Pressure
relief valve.
relief. Yeah, that's applicable only for air. What you are talking about this?
The vacuum relief valve or pressure relief valve?
No, pressure relief. Pressure relief.
Pressure relief valve, we can use it for air, we can use it for water, oil, gas.
Well, if you are using for water, the water should be it releases out or any other within the system it has been released.
It's a valve. It will open and that outside that. Just I will show the valve of the pressure relief valve how it will be.
No. Okay. Right. It's
Just
clear.
so what happened whenever there's a valve, we have inlet and outlet, right? So when the inlet comes with fixed, normally the water will have the inlet side. Outlet side it will be connected with some other drain or based on the thing. For example, if it is steam, if it is a steam application,
Yeah.
yeah, if it is a steam application, there's in the open air, the steam will go in the open. If it is oil, they will take it to this oil tank, so that they will not.
Some outlet, okay, it has to be taken out. Okay, right.
Okay. Right. So shall I move on this? I think the function, based on the function, you understand, right? Okay, right.
Yeah.
So now classification of valves based on the operative of the valve closure. So earlier we seen that types of valves were like in classification based on function. Now we have seen that based on the valve closure. That means there is a device. The valve consists of three parts. One is major is valve body, and valve disc, and valve operating device. That is a device which is operated. So whenever the valve body is connected, the flow will be inside the happening. The flow is there. If you see, can you able to see my mouse cursor moving on that?
Yeah.
Okay. Yes. Super. So that there is a flow will come here and it moves like this. Also the flow comes here, it moves on this. So it needs some disc or some plate or some moving parts just to stop the flow. That is to stopper. So that the device is called we call disc. So that based on the disc only we'll classify. Generally it is quarter ton valve. It's classified into two types. One is quarter ton valve, one is multi-ton valve. So quarter ton valve is nothing but it's a ball valve. Our general ball valve or is a tab what we are using right now. Only 90 degree it will move. So it's if you turn that handle to 90 degree, it will operation will change close or open. So when the valve is open condition, if you open that, if you change the handle to 90 degree, it will move to close condition. Again, if you change that again to 90 degree, it will move to open position. So that type of valves, ball valve, butterfly valve, all called as a quarter ton valve. That means only 90 degree it has to operate. Also, it is called as quick closing valve because within 90 degree we are operating now within 1/4 of the rotation, not even full rotation. 1/4 of the rotation we make it as the changes of the open or close. But in multi-ton valve, if you see that the multi-ton valve is a olden days tab, we have to rotate multiple times of the tab to close or open. In school days and all, we used to have that same tabs. So by rotating the multiple times, those are open or close. Even gate valve, globe valves are considered multi-ton valves. So we rotate this handle to move the stem and the disc to multiple times to open the disc or valve.
Which is the stem actually? So you said disc is the red color one, correct? Then you have an operator which is the orange color. Then you have the body which is in the light brown color, correct?
Exactly.
So,
But in the top portion, which is shown here, brown, that brown is the body, and this is actually a disc, and the green is the stem. Actually, green stem means it's showing it's a small thing. It's like a plan view. If you are, that is not a cross-sectional view; it's a plan view. And in this bottom thing, the regular bottom portion of the bottom of this like a globe kind of thing. This is a semi-sphere. That portion is a disc, and this portion is a stem, and this is a handle. So this is actually hand wheel. By rotating this hand wheel, the stem.
So the water that is stopping the flow is the disc or the stem that comes up.
Disc is the device which stops the flow. Wherever the stops, it's actually the flow that is called disc.
Okay.
And operating the device, the part which is operating the disc, no, that is called stem.
Okay, yeah.
So which is the part which is moving the disc to open or close.
Okay.
Okay, right. So this is called multi-ton valve, called quarter ton valve.
I think I'm a bit confused in this. I think when you see the actual picture of the wall, I'll have a little bit clarity.
Yeah, correct, exactly. This is a constructional view. I will next upcoming slides are coming that actual view. Just I can able to show you that.
Oh, done, done.
Or else I can use run some videos about this quadrant multi-turn valve to understand how it is functioning.
Yes, that will be great. Yes.
Just
Yeah.
I will run that. That is better. Just a minute. Just I am opening that video.
Take your time.
Can you able to see my that video?
No, actually.
Can you all see my video?
No.
No, no. Okay.
No, the PPT is there.
Okay.
Or I can send the link. We'll see that later.
Yeah, we could do that also.
Yeah, no, just a minute. Just I'm sharing that. So this is a actually is a globe valve.
Okay.
This is yellow color is body and green color is disc and this white color is stem and the red color is hand wheel. So now it
Okay.
is open condition. So this is the valve seat area. So this is called actually body seat, and this is a disc. So the disc will actually sits in the body seat. So these
Correct.
two portion only is controlling entire valve controlling area. So this sits properly and it's that area is properly fine and it's good condition. The valve will not leak at all. If there is some damages, scratches in this area, which leads to leakages in the valve.
Yes. Okay.
Okay. So now just moving there. This will allow whenever rotate that it will goes down and it's stops the flow. So this is a seating area. This is a seat ring and this is a disc.
Disc.
This
Okay.
actually is a removable part in the body.
Mm-hmm.
So the stem, that is the stem, and this is a flow stops. That is a that gray color is this flow or liquid which is not it stops beyond
Correct.
that. So when we open that automatically it starts opening. These are the types that details is not required now. We'll make it clear.
Yeah.
This is actually gate valve. So that earlier we seen this is how we have to rotate multi-turn valve.
Okay.
So this has to open. So gate valve actually earlier we seen that globe valve that is actually it's like a Z type flow. That is there are 3-4 types are there. That is Z type flow. This is actually is a straight line flow. The disc will move up and down. It's like a wedge. It's like a wedge kind of thing.
Correct.
This is a disc and this is a seating area. And if the disc will comes down, the flow stops. And if it moves up, the flow starts.
Correct. Yeah. Got it.
So this is a movement area. So this is what sometimes due to the if you are kept in intermediate thing, the disc will move like this. Due to oscillation, it may get tampered or wear and tear will be there. So that's why we this valves under we have to use only for on and off, open and close position. We cannot keep it intermediate position. So if you fully open, it will goes up and it locks here. So the disc will goes in this area. And this is a right angle valve, the same globe valve only. That is straight valve. This is right angle valve. So the valve moves and it's the flow will be in right angle perpendicular position. It's called angle valve. And this is also one of the globe valve with screwed end. And this is actually a plug valve and it's a ball valve. So this is a ball valve, cut section view, body, and inside there is a ball. In ball, that is a hole will be there. That is a hollow will be there, which allows the flow.
Correct.
So there is a handle is there. Right now, if the handle is against perpendicular to the valve direction, that means valve in closed position. That is also by visual because we cannot see what is the ball position inside. So initially we have to keep in this position only. So when it is perpendicular to the line, that is a valve in closed position. When it is inline to the line, valve in open condition. So the only 90 degrees is required to open and close. That's why it's called quick closing valve or it's a 90-degree quarter turn valve.
Like a tap.
Like a tap, exactly. So butterfly also is like that only, same. This is actually check valve. This is what I would like to show you. Okay. So whenever the flow starts, it goes up and the flow will be there.
Okay.
When it stops, the flow, return flow will comes, automatically the disc also comes down. Due to gravity itself, it comes down. That's why it's called swing check valve. We can use it for vertical application, horizontal application, vertical only to from bottom to top. But is mostly recommended for horizontal application. And this is one of the things, ball type check valve. So the ball will move up in the flow. When the return flow comes, suddenly the ball goes down and stops. Ball type check valve. Okay. Now we'll move to again PPT.
Yeah, thank you.
Yeah. Can you able to see my screen now?
Yeah.
So now I hope you understand this quarter turn and multi-turn function.
Yes.
Yeah. So based on the motion, again that is it's similar to the previous slide only. It's based on the motion, like linear motion, rotary motion. So linear motion means the disc will linearly move up and down. It's like a small linear movement. Rotary motion is rotation. So this rotary motion, ball valve, butterfly valve, disc valve comes into rotary motion. That means the ball will rotate. It won't move up and down. So that type of valve is called rotary motion valve. All quarter turn valves all comes under this rotary motion valve. Same way, linear motion valve means that gate valve, globe valve, check valve, which moves up and down, which leads to linear movement. So all this multi-turn valve comes under linear motion valve. So next we will move on to this N connection. So apart from that, next if you see N connection. So for example, any valve is we have to connect with the pipeline, right?
Yeah.
So when we are connecting, there are various type of connection methods are there. So majorly 6 methods are there. We have to connect the valve. So screwed ends. Everybody knows that the threads will be there. We will tighten it with the thread of the matching pipe. So that is screwed ball valve, screwed gate valve also is there, screwed check valve is there. So strainers are there. So screwed means threads will be there, so that we can match with the piping threads. So there are various types. Female thread is there. Male thread is there. Female male means when the thread is coming inside the valve, inside the body, it is called female thread. When the thread comes outside that body, it's called male thread.
Okay.
So this is female means both the side is female that inside thread. Male means both side male thread, outside thread. Female means one side inside thread and another side is male thread.
Outside.
That model also available. So also the thread also having various standards are there. British standard is there and US standard is there. So that's why BSP is a normal standard which we are using all over in India. We are using standard as BSP. BSP also is that means little bit of tapper is there inside the thread area. And one of the another thing is NPT. So NPT is one of the thread standard which has the narrow thread. Generally, this will be used in all most of the US, UK, and all. They have this NPT threads. NPT is basically screw tightened without any sealant. So BSP thread, we need some sort of Teflon thread or any thread or thread ball and all to lock the both, because when you are tightening both the thread, there is a chance of leaking in between the threads.
Correct.
So for that we have to apply some sort of external thing like Teflon tape or solutions or something. We have to put the threads and all they will put. So that in order to.
So NPT doesn't need that.
Yes, NPT doesn't need. It's like a little bit of tapper will be there. So that leads to initially it will lose easy to tight. When it goes upon 3-4 threads, automatically get tightened. That way we cannot tight more. So which leads to there won't be any leakages. The metal to metal seating will be there.
Isn't that always better?
NPT is actually better, but it's we cannot do multiple times. So whenever if there is a damage in the thread, there is a chance of leakages. But in all industrial process application, they will go for NPT.
So in case if your NPT is still damaged, then can you apply Teflon tape and use a template?
Yes.
Okay.
That is not an issue. Yes. Next, apart from screw ends, next if we go the flange ends. So flange ends means next this is called flange. So normally the flange is the thing is easy to remove and fixing, because in threaded we have to once it's fixed we cannot remove it by easily. We need to cut the pipe and then remove it, or else we need to give union to remove the pipe. But here we can give directly. We can two flanges. We can joint by bolt.
So in the second one, the flange end, directly you can insert the pipe in the gap itself, right?
No, we cannot insert flange. Pipe also has to put one flange.
So there is still a thread inside. No.
No thread.
Okay.
The same type of flange will be there. That flange, both the flange will get matting. It's like two hands getting together.
Okay. So then the flange of the pipe also should match.
Yes. That's why we have to standard of the valve is more important. For example, if you take PN10 rating is there, PN16 is there, PN20 is there, class 125, 150, table E, table D. So that kind of various classes, various standards are there. So based on that standard only, we have the PCD that holes will match. Otherwise, that will not match.
Okay.
So we have to buy if you are making a flange end valves, or if you are supplying a flange valves, we have to tell them we are supplying a flange of PN16 flange, or we are supplying a flange of 150 class flange, so that they will buy a same flange in the pipeline.
Okay.
Otherwise, it will mismatch. So that's why we also have to flange it. Also, the pressure, the PN10, 16, 20, 25 is a pressure rating. That means the pressure it can withstand up to 10 bar pressure. PN16 it can withstand up to 16 bar pressure.
So PN rating is your pressure bar.
Yes.
So for the flange type, how do you refer that? Classes, is it?
Yeah, based on the pressure that flange holes all drills will happen normally. If you
No,
supplying,
no, no.
if you
If I
supply,
have to buy the no, if I have to buy the flanges for the pipe,
hmm,
correct? How do I
hmm.
know what is the flange for the PN16 like 200 psi this thing?
Same thing, you have
PN16.
to ask for PN16 flange only.
Okay. So it's the same. So that will match.
Yeah, it's all classes standards are matching with the flanges.
Okay. So what is this class 125, 150, 300, all that?
This is American standard, ASME standard. So class
Yes.
125 is a pressure rating. It can withstand up to 12 bar pressure. So
Okay.
150 class, we test the valve for up to 20 bar pressure.
Mm-hmm.
So which I am telling is all our seat test pressure. Seat means we have to close the valve, we test it whether the valve is leaking or not.
Okay.
That pressure, the maximum pressure it can test.
Hmm.
So 150 class rating means we can test it for 20 bar. So if
Okay.
it is 300 class means it can test it for 56 bar.
Hmm.
So another one test they will do apart from this seat testing. The seat testing
Mm-hmm.
means we have valve closed condition. They are testing whether it is leaking or not. But we will
Mm-hmm.
also do one more testing called open condition. That is called body
Mm-hmm.
testing. That means we will close both the end of the valve and we will give
Mm-hmm.
pressure on one side and see whether the body of the valve withstand about the pressure.
Correct. Okay. Yes.
That testing we will do 1.5 times higher than the seat test pressure. So, for example,
Uh,
if you are testing 20 bar pressure of the seat, we have to test
mhm.
30 bar in the body.
Okay. Yes. Got it. Yes.
So,
So
when
you're
we give
taking
30,
extra factor of safety of 50.
exactly, factor of safety is 50. So, whenever there is a 1.5 times the pressure is given inside, we will see all the joints are working or not, all the joints are leaking or not. So, we'll check that
Mhm.
joints.
Okay, got it.
So,
Yes. So
on the body.
PN10, so PN16 is 200 psi, PN2025 is 300 psi, right?
No, actually, correct speaking is PN14 is a 200 psi.
Okay.
So if somebody is asked for PN16 as 200 psi means there is a class will comes. It's better to quote 300 psi for PN16.
Okay.
So if you are going for 300 psi, we have to go for both the PN16 as well PN20. Both is 300 psi only.
Mm-hmm.
If the client accepts, because some standard 200 psi will says, but we are testing the valve for 200 16 bar only. But still
Okay.
200 psi, if you convert it to bar, which will comes under 14 bar.
Okay.
So nearly 14 bars. So that's why we have to go for PN10 or PN14. Like that we have to say. Or
Okay.
else directly we have to say 200 PSI only. That value is 200 PSI. That's all.
Okay.
We cannot go. We cannot map directly to PN16 to 200 PSI.
Okay.
If they want 16 bar means then they have to go for 300 PSI.
Okay.
Okay, right. So now the flanges are you are clear, right? That is I have mentioned
Yes.
two things: FF and RF.
Yeah.
So FF means flat face, RF means raised face. So flat
Mm-hmm.
face means if you see this area, it's fully flat. There is a small projection over there. That is the projection is there. I think I can show you the flanges, the valve body. Yeah, this is called a flat surface. So
Mm-hmm.
wherever there is no projection and all, there is flat. It's a flat surface. This flange
Mm-hmm.
is called flat surface. These holes are not the bolt holes.
Yes.
This is the one we have to match with the matching flange. That is where, based on the standard, that holes will match. That's called PCD. PCD, pitch
Okay.
circle dia. So from the center, if you measure, all holes are eventually there is a same distance. That
Yes.
distance will be measured. Is a standard is there.
Mm-hmm.
In raised face, there is a small projection below this bolt hole as well as that above the that inlet line. That will to
Mm-hmm.
hold the gasket. That is called raised face. In
Okay.
high pressure and all, we will have the raised face. Low pressure, we will have this flat surface. flange.
Mhm.
So now then we'll move on to this butt weld ends. So all these two are common. Screwed and flanged end are common everywhere we are using in all sectors. In butt
Mhm.
weld, socket weld, and these two are majorly used in industrial or steam lines, wherever the pressures or chemical line, wherever is very important materials are going, we'll use this kind of thing.
Mhm.
So when butt weld means that we have to, there is a, we will keep this both valve and the pipe, it will be same dia, it will match that, and it will automatically, we will weld that, we'll join, we make the joint with the welding.
Ah, okay.
So butting both the thing and we weld it. That is
Mhm.
called butt welding. Socket welding means that if you see this valve, inside there is a hole that instead of thread there is a flat surface will be there. We'll insert the pipe inside like a PVC pipe.
Correct.
If you are pasting it when you insert it, that is called socket type.
Mhm.
The same way we'll insert the pipe inside this material inside the valve and we weld in the outside.
Okay.
So with the pipe, that is called socket weld.
Mhm.
Excuse me, one small thing. Hello.
Yeah.
Can you hear me?
Yes.
Sorry.
Yeah, yeah.
Yeah. So wafer type ends. Wafer type ends means is actually is a butterfly valve and wafer type check valve. These are two types are we using in wafer type. The
Mhm.
wafer means there won't be any thread, there won't be any flange. It's like a wafer biscuits. So what we will do, we'll have two wafers. In between, we will have that sandwiches or we'll have that chocolate thing. We'll wafer that. That means there is no threaded connection or there is no flanged connection. So then how we will mount the pipe in the pipeline?
Mhm.
Mm, that I will show you later. That means we'll keep in the two flanges. In pipe we will have the flange. So
Mhm.
we'll keep this valve in between the flange in between the two flanges. So
So, so you'll basically take a, so you have a pipe out of which the flange will come out.
okay.
So, the external flange you'll fix this thing, right?
Yes, we'll keep the valve in between the two flanges and we'll put the bolt nut between the two flanges. Normally, here what we'll do, we'll have one flange, the bolt will come between these valve flange as well as pipe flange. But
Correct.
in this wafer type, that bolt will directly goes to this flange to that flange. That means in between the valve will not have any hold or any connection. It's only stuck in between the two flanges.
I think when we later on we see the flange, probably we'll have better idea. It's
Yes,
okay.
better. That's why I will show you later. Okay.
Yeah,
And
yeah.
crudent is and the another thing that also I will show you the images later. Is it's instead of flange or threaded, we have a groove type. It's like a clamp on type. If you see olden days, we have that boiler and all. We'll clamp that boiler like with that small external clamp.
Correct.
So, it's like a joining two pipes with a clamp. That is called grooved. That I will show you later the image so that it is easy to understand.
Mhm.
Okay.
It's like your basically your standing fan that comes, right?
Uh, Standing.
You know the standing fan
Standing. Yeah. Standing fan.
when you,
Yeah, we have the top cover. We are clamping that, right?
yes, the top and the top cover you're clamping towards the whole outer body.
But that is we have separate the 3 4 clamps and in the body itself we clamp it, right?
Correct.
But here is
Yes.
not. We don't be like that. It is a separate external ring will be there to join the both
Uh,
the things.
but similar concept.
Similar concept, exactly. Similar concept. Okay. Shall I move on the next classification?
Yeah, right.
So next is the material of construction. So this is major important based on that application where they are going to use, what is the purpose they are going to use, what is the function, what is the pressure. So material of construction will come. So these are the various material of construction which are using our valve. We are manufacturing valves. Cast iron body, ductile body. So both are cast iron only. Ductile have some sort of ductile ability. So it has that extra additional of manganese and all to in the chemical composition. So cast iron is the base material. If you go next, it will goes to leads to carbon steel. So it will have a little bit costlier than cast iron, and then stainless steel. All these are iron material. That means ferrous iron is there inside. The major composition is iron. So cast iron is we cannot weld it. We cannot. It's brittle in nature. If you put in, if you keep the, if you drop the valve from the height, it will get cracked.
Okay.
It don't malleable, it don't bend, it don't have that ductility. But in ductile, little bit of ductility is there when compared to cast iron. So these are the two major materials. We are manufacturing valves in ductile alone, because in cast iron there is a chance of cracking even in the line when they are installed improperly. So uneven condition when they are clamping the flange and it's uneven condition, there is a chance of leading to failure of the valve. That's why we have this ductile body which will withstand that kind of stresses and all.
So I think for the higher size, it's better to go with ductile body then, right?
Yes, we are manufacturing with ductile only, but in body sometimes it may return as cast iron.
Okay.
In catalog also sometimes we return as cast iron, but due to safer side we are manufacturing ductile. All our gate valves, sluice valves, check valves, all are ductile only. Okay. Next composition is brass. I think brass, bronze, gunmetal, all are copper alloy. We call it as copper alloy metal. So that means the major components is copper. So if you say brass, bronze, gunmetal, all are copper, then what is the difference is, if you mix the copper with zinc, then that metal is called brass. If you mix the copper with tin, that metal is called bronze. If you mix copper with zinc tin, then it's called gunmetal.
Okay. So zinc is least expensive, right? Among the tin and this thing?
Yes, exactly. So brass is the low cost product.
Okay.
So brass actually it has when we are doing a forging it will be economical, but when we are doing a casting it will become costlier based on the weight.
Correct. But when you compare brass wall to the cast iron wall, your brass wall is expensive, right?
Depends upon the sizing, depends upon the product. We cannot, because brass generally costing based on the weight of the valve.
Okay.
So we can able to take the valve comparison. You can able to compare, because wherever the brass possible least place, generally they will go only for brass. They will avoid this kind of cast iron and all. Two things. One is brass. We can able to is a good to health also. So you don't get corrode and all. Corrosion will not be there. Another thing is resale value. It has resale value. So if you throw it as a scrap, you will get a good value. In foreign countries and all, they use copper tubing with the brass or bronze metal only. Valves, most of the things. Okay. Next, carbon steel. Carbon steel is one of the derivative of iron. As I said, cast iron is the base metal. Next, carbon steel. It has a malleability. It has carbon content. So that's why it's called carbon steel. Stainless steel is there is no carbon. That is what where there is one, because of carbon link, the carbon steel get rusted. Carbon steel also is called cast steel. Also, it is called as mild steel. All this comes under this carbon steel only. So galvanized iron, GI also they will say GI. That also
Correct.
comes under carbon steel. So GI means that is nothing but carbon steel, carbon steel with mild steel with GI coating, galvanized coating. So with the galvanized method, they will do some galvanization of the valve outer body.
So it's basically iron with galvanized
Iron.
coating.
Yes. That basically the mild steel with the galvanized coating. Okay. Next, stainless steel. There are various types of stainless steel grades are there. basic, it's 304. If you say SS, they have to give 304. That's what general term. But somebody will play that with other lower grade metal like 202 and all, which will get corroded, which is actually is little bit of superior than carbon steel, but it will get corroded in overall period itself. So stainless steel means we have to go for 304. Next grade is 316. So if you go for further low carbon, that means we go for 316L and 304L. That is majorly used for salt water applications. Next, the triplex metal also is there in stainless steel.
So you said for the salt water application, what is that?
316L material, which will least get corroded because of salt, alkaline metal. Normally, stainless steel also will get corroded or get worn out quickly because of salt content.
Okay, because in Qatar, I think generally they use this in some areas.
Oh yeah, correct. So in our refineries, some atomic power station nearby sea, they will use desalination plant. They'll use minimum. I'm telling minimum is the 316L grade.
Okay.
Beyond that, there are some more grades, duplex, triplex, which will be more superior than this 316L.
Okay.
Then alloy carbon steel. So alloy carbon steel is actually carbon steel which is a mixture of some extra additives to improve the properties of the carbon steel. So that will also have some sort of to avoid corrosiveness, to withstand some chemicals. So the various type of alloy carbon steels are there. That grades and all we give later. That's very industrial oriented products. Next, PP again plastic materials. If you take plastic materials, that PP is one of the material. UPVC, CPVC, PVC, HDPE. So everything have individual own properties. Based on that particular requirement, we have to select the product. But basically, in valves, if you take PP is one of the product which is in chemical line or any other more corrosive line, they use PP material, PP valves. Okay. Next is special alloys. Apart from that, there are special alloy materials are there. That cast alloy and some more materials are monal. So these and all very specifically they will call for. So that and all we can go whenever is required. Okay. So next I'm moving on to the next classification based on the operations. This is one of the things already you know that operation means the manual operation and automatic operation. So this is the thing how we are operating the valve. So when we are operating the valve by manually, by hand wheel or hand lever or gear wheel or chain, all these are comes in the manual operation. Hello.
Yeah, I can hear you. We can hear you. Yes.
Yeah. So whenever this manual operations, the hand wheel means that is what we seen in all gate valve, globe valve. Hand lever is like in ball valve, butterfly we call it hand lever, and the gear wheel. So that means gear operation. That means instead of hand wheel and for butterfly valve, if you take a butterfly valve, up to 8 inches we have hand lever operated. Beyond that, we have to go for gear operated only, because the torque or the load which we have to give to open and close will be higher. So that time is difficult. It's to convert. It's like in car we have the power gear and olden days normal gear. Now power steering, normal steering.
Yes.
That concept. So gear operator and the lever operator. Next chain is to in the gear operator only we have to use. The chain is to, if it is a valve is in the height, we have to operate, means we will put a chain and we will operate it. That called is the chain operator thing. Is like is a customized product. So whenever is required, they have to provide as a chain. And for automatic, in automatic category, we have this electrical operated, pneumatic operated, and air operated. So yeah, pneumatic operated, air operated means same only. That is whenever if you give a pneumatic air inside the actuator will open and close the valve based on our command. That is called pneumatic operator valve. Electrical operator means it's actuator. So motorized valve. Have you seen this motorized valve in any anywhere? Even nowadays, gates comes under automatic gates, no?
Correct.
That also the motors are there. So what it will do there, if you press the switch, the one gate will open. If you press the off switch, gate will close. So likewise, we have the valve also. We put a motor electrical actuator over the valve, and we will operate electrically. So manual stress is not necessary. By using electrical thing, we can able to automate also. That means based on some inputs, we can open. Like when the car comes in front of the gate, it will automatically opens. It will sense the sensor will be there. The sensor will use the command to the control box, and control box will command to the electrical actuator to open.
So even for like normal high-rise building, correct? So
Yeah.
you don't. So say you have like example Qatar where labors are really expensive, right? So instead of
Exactly.
going manual operation, can you go for this basic electrical motor operation, right?
Yes, exactly. We have to do that. So that
Okay.
is what now actually in, for example, so if you want to divert multiple places, like if you want to fill multiple tanks, say one pump is there. If you are filling
Correct.
5 tanks, so if you
Yeah.
are filling 5 tanks, we have keep 5 valves over there. What they generally they will do, they switch on the pump and they will open the valve one valve, and when the tank is filled, they close it and they will do the next valve to open. So like that
Yeah.
they fill multiple times. Instead of that, we can put motorized all 5 motorized valve and put a
Mhm.
level sensor in the tank, and we'll have the common control box, and will the sensor connect to the control box, and the control
Correct.
box will connect to the electrical actuator valve. What it
Yeah.
will do, whenever there is a low level, the valve will open automatically. Whenever
Yeah.
the tank reaches high level, the valve will close automatically.
Correct.
So
Yes.
like this, 5 tanks automatically get filled up. So in
Mm-hmm.
pump side, we have to do separate automation so that whenever any valve open, the pump has to switch on automatically. And whenever the all valves are closed, the pump has to off. So that kind of pressure-based automation we can do separately. So that is a automation, we call it as automatic overtime level control system or pump control system.
Mm-hmm.
That we will see. We have one product for that, one special product. We are the actually pioneer in that. So we will have a detailed presentation about that in later stage.
Okay.
So that kind of operations here, air and pneumatic also. Instead of electrical thing, we have go for air, pneumatic air, because the electrical actuator is costlier than pneumatic actuator.
Mm-hmm.
So here, in compressor, normally in industry side, they have the compressor too for various applications. So they
Mm-hmm.
need air for various applications. So what they will do, they instead of going for electrical actuator, is a costlier one, they'll use pneumatic one. Also, electrical actuator needs some time to close and open, where it's
Yeah.
pneumatic actuator is a fraction of second get closed, fraction
Mm-hmm.
will get open. It's very faster. So we can give a air of 8 bar pressure, 7 bar pressure in the actuator. So open and close, there's a 2 port will be there. So they will
Mm-hmm.
change the direction. When that open port is the valve is open, that means open port air is given, the valve will open. If we change
Yeah.
it to the close position, the valve will close.
Mm-hmm.
And hydraulic. So apart from these two, yeah, hydraulic oil also can be used to control. Hydraulic
Mm-hmm.
cylinders, hydraulic say pneumatic power packs are there to operate the automatic control system. That and all industrial application, that's specific things are there. We'll see later for that.
Yeah.
Okay, shall I move on to this? I
Yeah.
think already I said most of the thing about the products.
Mm-hmm.
So now we'll come to the type of the products. What are the products what we are manufacturing? So this is the basic. Not all is a general usage products.
Mm-hmm.
So brass ball valves, lead-free brass ball valves, gas ball valves with other MOCs, butterfly valves, strainers, pressure reducing valves, pressure relief valve, sluice valve, gate valve, check valves, air vent valves,
Mm-hmm.
and water immerser, manual water meters, electromagnetic flow meters, FM approved utility management solutions. I hope, I think if I go to each and every product, so it will become more load to you right now. So we'll break up to this level. So based on the classification type of faults I explained. So we will
Yeah.
see in the next class about the detail about the products as well as the individual products.
Sure. Sure.
Yeah.
Thank you.
This
Thank you for listening to me patiently, and it's
yeah,
made it
it's
more interactive. That is what helped me to
yeah, yeah.
continue without any struggle.
Thank you. Thank
Yeah.
you so much, Raja.
Yeah.
This is whatever we have done the PPT. Only that portion is possible to mail us.
Yeah, sure. I will mail you, sir.
Yeah, so next time
So,
what we can do is we can take a printout of this and we can make notes on the same page, it's easier.
Exactly, exactly. So what do you want to PPT before that itself so that you can understand previously.
Correct.
yeah. So that we can also prepare and then get ready.
Exactly, exactly. It will be easy for you to understand when we are explaining,
Yeah.
right? Okay, okay, no problem.
Right.
Thank you.
Thank you.
Thank you so much, Raja. Thank you. Have a good day. Happy Diwali to you.
Thank you. Same to you all. Right.
Thank you. So I'm just disconnecting.
Uh, yeah, please. Yeah, right, sir. Thank you.
Thank you.
Sanjay, are you there? Abbas sir?
Yeah, I'm here,
Okay.
sir.
Yeah, it's closed right now. Session is over. So they are closing. They are moving off, signing off there.
All right, super.
Okay. Bye bye. See you
Great, guys. Thank you for joining. We'll see you again next Saturday.
next
Happy
Saturday.
Diwali.
Yeah, Saturday. Right. Thanks.